You are hired by the City Council of Centerville to do a population study. A small factory closed in the village of Centerville 6 years ago. Sadly, Centerville has seen a decrease in its population because of the loss of employment. You are hired to make a prediction about the anticipated population of Centerville for the next 3 years. Your prediction will allow the City Council to plan for the downsizing of different departments in Centerville, fire departments, schools, and etc. So for this problem, we are going to use the standard form of the exponential function, which is y equals a times b to the power of x, whereas x represents the number of years, y represents the total population, a represents the initial value, or population, and b represents the common ratio. So the first thing that we notice is, as shown in the table and in the situation, this function will represent an exponential decay because it is stated that there was a decrease in its population and the numbers have also decreased as the x value increased, which shows that there is a decay, in contrast to a growth where y values increase as x values increase. This also tells us that b is less than 1 but greater than 0 because numbers that are less than 1 but greater than 0 recursively multiplied are basically finding the fractional portion of the previous number. So the following number will be less than the previous number. Now let's find the exponential function when given 2 data points. To start off, we're going to round off to a whole number because humans cannot be represented as a decimal. Now, these are the 2 data points that are given. As you can see, the x value has increased by 3, meaning 3 years has passed in context because x represents years. And in the span of 3 years, this population was multiplied by the common ratio b 3 times since 3 years has passed, and it resulted in this population. So we know that 16,333 was multiplied by b recursively 3 times, so we can actually write this as an equation. 16,333 times b to the power of 3 equals 14,907, rounded up. So now we can actually solve for b. To do this, we have to isolate the variable, so let's divide 16,303 on both sides first. Then we will get b to the power of 3 equals 14,907 divided by 16,333. But we cannot end it just here because in the equation y equals a times b to the power of x, we are solving for b only and not b to the power of 3. And to do that, there are 2 methods. We can either find the cube root on both sides to get rid of the exponent, or we can raise both sides to the power of 1/3 because that will cancel out the exponent. So our final result is b equals 14,907 divided by 16,333 to the power of 1/3. And this, when you calculate it, is about 0.97. So this is our value for b. Now that we have solved for b, let's find a to finish off our equation. To find a, we can actually use the method of substitution, because in the default formula y equals a times b to the power of x, we know the value for b, so we can substitute it. We can also replace the value for y and x with one of the given data points over here. Let's use the top one to replace it. So instead of y, we're going to use 16,333 equals, we don't know the value for a, so it will remain a, times b, but it is 0.97, to the power of 3, since x is 3 for that data point. So we can actually solve for a now. To do this, we have to isolate it. So let's divide 0.97 to the power of 3 on both sides. Then we are given with 16,333 divided by 0.97 to the power of 3. And we are given a directly, so we don't have to change anything. This is approximately 17,896. So this is our value for A. Now that we know the value for A and B, we can make our formula. So y equals 17,896 instead of A times 0.97 instead of B to the power of x. Now this will be our final equation. Now let's change this to a function notation to make calculations easier. To change it to a function notation, we can simply replace y with f times x, where x represents the number of years. This equation shows that whatever value is inputted for x here, it will impact this value. So fx is the function of this. Now that the equation is defined, let's jump to the graph. But before we start, label the graph so it is easier to read what is going on. To do this, press the wrench icon on the right top corner, and the x-axis, like I said, it represents the number of years, and the y-axis represents the population of Centerville. Now we can type in the function that we made. Once you typed in your function, you should see a graph that looks like this. If you cannot see it, then frame your graph so that x is greater than or equal to 0 but less than or equal to 100, since we only need to see about that many years, and so that y is greater than or equal to 0 but less than or equal to 20,000, because we can predict that the population ranges between 0 to that. Now hopping back onto the graph, the two green dots that we see actually represent two data points that were already given to us. So this dot represents the population for 3 years, since the x-coordinate is 3, and this represents the population for 6 years, since x equals 6. Like so, we can continue to use this graph to predict the population for whatever number of years. The initial goal of this problem was to find the population for years 7, 8, and 9. And so we can do that by trying to find the point when x is 7, which is about 14,460. And for year 8, we can do the same thing. Stop when x equals 8, which is 14,026. And for year 9, 13,605. So that is one method on how to solve for the population when it is year 7, 8, and 9. Another method to find the population for when it is year 7, 8, and 9 is by using the table, and we can fill out the table by using the function that we have solved for. So to do that, since we know that x represents the number of years, we can input 7 for x, and that will give us the population for that year. When we calculate it, it is about 14,460. And so this will be our population for year 7. You can do the same step for years 8 and 9. These are our results for year 7, 8, and 9. Now we can hop back to the table and fill it out. And it is that simple. Or if you want to do this really quickly, you can simply just replace y with fx, and if you just type it in, it will give you the answers automatically. So that is how you can predict the population using the table, the function, and the graph. Now going back to our situation, it said to use the data points to complete your task of finding a function rule and determine the anticipated population of Centerville for the next 3 years. So we can actually write our final answer. And that is it. That is how you find the function rule when given 2 data points, and how to find the population for the next 3 years. Hope this video helped. Bye!